Okay, hello everyone. Welcome to a design review for functionality for Wolfram Language 13.1, which is hopefully coming out soon. I believe we have a very busy live streaming day today. It looks like there are 4 live streams scheduled. So I have a busy day every day, but this is going to be a visibly busy day, perhaps. Okay, we have started in on calculus and algebra last time, and I think we got down to this section about implicit D and so on. Is that correct? We had gone through these things at the top here, right?
Yeah.
Okay. And implicit D, I think it would be really good if, there's a lot of stuff from Adam here. Maybe we should ask Adam to join. Yeah, please do. Can we do that?
Yeah.
Can somebody go find him, please? Yes?
Yeah.
Thank you. Okay. So is this in the system, or do I need to look at the source code for implicit D? Do we think we finished with implicit D?
I mean, for reference pages, you always need to look at the source. For implementation, you can use prototype build.
That's what I'm using.
Yeah.
Okay. Oops. Okay. So implicit D we had started talking about last time, as I recall.
Yes.
But we finished or not?
Well, more or less, we sort of, we kind of ran out of time. So
okay, let's take a look at it again. Okay. So the assumption comes first here.
That's a special case. Normally, the function that you're going to differentiate comes first.
Show me a non-special case.
Sorry?
Show me a non-special case. All these ones here seem to be of these special cases.
No, only the first one is the special case. The rest of them are the general case. See, that's a function there of both x and y.
I'm sorry, okay. What are you computing? I mean, if this is a special case, for goodness sake, don't lead the documentation with it.
Well, the vendor thinks that they're very important and are,
Well, the vendor speak up.
Yes, so the point here is that people require this all the time.
So just explain to me okay. This is
literally saying the function y
as a function of x, as a function of x with this constraint.
Yes.
Yeah.
Okay, so now what's this here?
You would get the same result as the first one if you said implicit D, y, comma, and then the rest that's up there in the first example.
Yes.
Okay, the second derivative of, okay, so hold on. Let me look at this for a second. Okay. This has 4 arguments.
Mm-hmm.
This has 3 arguments.
Yes. And they're an implicit y as the first argument. This is basically saying y as the first argument.
Yes.
Okay, so then if I take this and I were to explicitly run this implicit D, where I say here, y comma that.
That should give the same answer, exactly.
Okay, so explain to me. Okay, so this is the derivative of y with respect to x, where the y that I am differentiating with respect to x is this first thing here.
Yes.
Yes.
Okay, so if I said 2y, for example, I would get that.
Yes.
I personally think the first example should be this. And I think we should, then we should say, alternatively, you can, I don't know, I would just use this.
No, I think that's fine, Stephen. I think that I think the vendor's point is that this is how it's often presented in a calculus textbook.
Yes.
Fine. We can go to that as example 2 or 3 or something.
Fine.
Right?
Yeah, sure.
Okay. Because you're saying you're differentiating this with this constraint, and this is the dependent variable, and that's the independent variable. Is that correct?
That's correct.
Yes.
Okay. So now my only question is, when you give, okay, you've got the thing and its constraint. Other functions that have a thing and a constraint, like all the optimization functions, how do they present their arguments?
Well, the first is the objective, second is the constraint, and the third is the...
What does constrainment? Well, I thought it was called constrainment. What's it called? What's it called?
Minimize.
No, but I wasn't. Okay, all right. So if we look at minimize, for example, okay, No, you see, that's wrong. That's not what there.
Yeah, we're trying to go.
constraint is an
We
ellipse.
want to go away from that form.
Okay, no,
That
no, no,
form-
no, 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 no. Don't hide it. Okay,
So
so
what are you talking about?
Okay.
We're going to go away from that form with list. That was in an earlier era.
Okay, Roger.
Yes.
Roger.
Yeah.
This is the mistake we've made too many times before. Let's do this a little bit more carefully,
Fine.
right? This is not we're going to make up charting stuff because we didn't like the way that list plot functions worked. Okay, let's understand what it is that we're making design incompatible. And the answer is minimize has the function and the constraint, right, in a list. Mm-hmm. So what functions don't work that way?
This is a little bit different in the sense that there's a bound variable. There's no bound variables here.
Bound variable in which case?
In the sense that you have a dependent variable y.
I'm sorry, in this case here for minimize, or in the case for implicit D?
Implicit D.
Okay. Let me understand this in a bit more detail. Okay, we've got minimize. What other optimization functions do we have, and how do they deal with their function and constraints?
No, they all minimize and n-minimize and find minimum all work the same way. They have the same syntax, so you can flip between them. What they don't do the same way is that some of them have special needs, like the numeric functions might need initial values.
Okay, I understand. Okay, where do those put those?
Well, it's different. Okay. So,
but Roger, but what you're saying is when there is a constraint like this, all the this is what I remembered. The minimization functions have the function followed by the constraint in a list. Is that correct?
Yes.
Okay. Now, which functions you're saying you want to go away from that? Which functions have already gone away?
Convex optimization.
Okay, that was the thing I was trying to remember. Okay, so let's take a look at how that works. Oh, God. Okay, so that has a function, constraints, and variables.
Yes.
Okay. Now,
and admittedly, I have to say implicit D, it wouldn't be the end of the world if it had sort of constraints and the constraint variables, the bound variables there in a group.
Yeah, well, let's talk about this. I mean, why did we change that for convex optimization? Why did we want F and cons not to be in a list?
It's awkward to package them up because constants themselves usually very complicated, and you want to sort of construct them separately.
Fair enough. Okay, so basically the point is, I mean, clearly, if it's called cons,
in the early days, we worked mostly on very small problems.
No, I understand, Roger. The point you're making is the constraints are usually big pile of constraints.
Absolutely.
The thing you're optimizing, the F, is usually comparatively small.
Yes.
And we're seeing that again here in the implicit D, where the thing you're, quotes, not optimizing, but differentiating is just Y, which is sort of small compared to the constraint, which is, the curve, which is bigger somehow.
Yes. Right.
Okay, but let's go through this again. Okay. It is unconvincing to me that just because cons is big, I understand, we could write convex, optimization of, x plus y, comma, big, if we wanted to, comma, xy. I mean, in other words, there doesn't seem to me to be anything obviously wrong with packaging those in a list.
Well,
right. I mean, I'm trying to understand, why did we make the decision to not package it in a list? Because the fact that this thing can be big is
I think that it's I've heard complaints over the years many times, and this was just, now we're working intensely in optimization. And this was a low risk thing to do for convex optimization.
I understand. Okay, so the question is for implicit D, to me, the very fact that I was confused here about this is an argument for packaging those things in a list, because that way you see it's not packaged, okay, it's the pure constraint. I'm not certain. I mean, by the way, did Adam join us?
Yeah, he's here now.
Great. Does Adam have an opinion about this?
He probably just joined. Yes.
Oh,
No, you don't have an opinion. Okay. Then
Adam just joined, so he's missing a little bit of context.
all right. Then okay, so we've got, oh boy. How is this case not ambiguous if you don't package these in a list? How is this case where it's a var args function not ambiguous?
I think that, well, there's the first three is probably always required, right? So
Yeah,
No, but they're not always required. Look at this case here. If I say equation, comma, y, comma,
yeah, so
x,
this was
comma, x,
this
comma, x.
one has to be an equation that we recognize it by having had the equal.
Or a list of equations.
No,
no.
just an equation. So this is a particular case for one equation, which is different from all the other ones.
But in this case here, I don't understand. Isn't the equation? I don't understand. How can this be represented by a single equation? Because it's on a line. I see. Because
But that
no,
case doesn't not
all-
supported in that first syntax. This says EQN,
Yeah.
not EQNs.
Okay, I understand. I'm not sure here. So, okay, so in this case here, what does this mean?
These are
I
the
can't see.
dependent variables.
I know, but how can there be? Aren't you looking at the variation? You're looking at the variation of this quantity with this constraint as you vary those variables. Is that right? Is that right? I mean, it's delta.
No, so you're looking at the derivative of the first thing with respect to x, the last thing, and y and z are functions of x.
But how do they enter?
So they are function of x that are defined by the system of equations.
So I see. So the point is you're varying that single parameter x, and you're asking how does this vary when you're on this curve, and why do you need to know these? Is that just because you need to know what is the? I mean, could we not deduce these in a typical case?
No, they can be parameters.
Okay, fine. So those are the things that are, but explain to me. Those are the things that are supposed to be varying. I'm a little confused here. Those are the things that are implicitly, as you change x with this constraint, these are things which are considered to vary as you vary x, maintaining this constraint. Whereas a parameter, a, you can change x however you want, but
it's a constant.
Yeah,
So
but it's a constant, right? Sandra is making the point on a live stream that convex optimization always has the constraint, whereas minimized does not. That is a good point. Right, that's correct, Roger and others.
Yes, it is.
Okay, so again, I'm asking, okay, the dependent variable list, there's a single argument for the dependent variables, but the independent variables, you could have a long sequence of x1, x2, x3 as var args, correct?
It sort of follows the D.
I understand that. I'm just asking the question because I'm trying to understand, is it an
Yes.
ambiguous syntax? And what Adam is saying is it's never an ambiguous syntax because the equation argument, which is, by the way, not a single equation as we see here, it can be a list of equations as we see here, right?
Mm-hmm. But that doesn't support that shorter syntax.
So the shorter syntax is just for a single equation and the derivative of the dependent variable rather than an arbitrary expression. So it's just a shortcut that's somewhat different in the syntax than all the other ones.
No, I understand. That's because in this case, as you're describing, that can define a line on a sphere and so on, as opposed to just a thing where there is a single, where there's a single variable that is where that argument. No, I'm now confused again. Where this argument has to be a single variable, right? Is that right? Okay, look, there's a binary decision here. I mean, I think we understand how all of this works, but for one thing, which is, should the equations be in a list or not? My tendency probably is to say they should not be in a list because they are so necessary to the whole story.
What do you mean by list? I mean, there are in a list.
No. I mean that they should be in a list with the F.
Oh, I see. Okay.
Okay. So my feeling is that what you've got here is right, that they shouldn't be in a list with F. Okay. So, I mean, anybody want to disagree with that? I mean, obviously, this is what you set up. So I'm agreeing with you at this point.
Okay.
The only disagreement I have is that I think the very first example should not be this example.
We can fix that.
Yeah, so you just want a Y. Yeah, Adam, I'll tell you later.
Don't
Yes.
put a single Y there. Put 2Y or something like
2Y.
that.
Okay, fine. 2Y is a good idea. Yeah, sure. Fine.
And then you're saying, then write out the words. You're saying derivative of 2Y or whatever you want, of Y plus 1 or something, you know, as, I mean, it's not really with respect. What would you say? What are the words? Okay, so assume that I've got.
It is with respect to X, actually.
Okay, so just tell me the words with respect to X, and then how do you describe the Y that's there? What do you say there?
Y is satisfy that equation.
Yeah, or Y is implicit function defined by this equation.
No. Just tell me the word.
They don't want to use
Derivative of. Okay, it's the derivative of 2Y plus 1, where X, with respect to X, where Y varies according to the equation blah, 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 or is constrained by the equation blah, blah, blah. Is that right? I think that's the right words.
Yes, yeah.
Constrained, definitely, not varies.
Right.
Yeah.
No. So where, okay, so we should capture those words, but that's basically what we have to say. And that's probably what we have to say in the original. That's what we have to say in the example. And it's probably what we have to say in the box at the top. Make sense?
Mm-hmm. Yeah.
Okay. Great. Let's move on. That's great. I have no other further comments on this. Looks good. Sorry, you guys are a little bit victim of the fact that I've got 4 design review-ish meetings or something today. So I want to move through these quickly.
I hear it.
Okay. Integrate change variables. Let's look at this now. Okay, so this I think is going to bring up the horrors of inactive things, right?
Yes.
I'm not sure we're going to be able to solve that here, and I think you should make this experimental.
We want to make it experimental.
Yes, that's fine. Yeah.
Okay, so just let me give a sense of this. So this is change variables in the inactivated integral. I mean, to me, really? Why isn't it an arrow here?
Right. So the equal sign is more symmetrical. We can do it the other way, but then you are constrained to give the X in terms of T.
I'm sorry, what are you doing here? In other words, is it the case? Okay, so you're saying change variables to the variable T.
Yes.
And then this is the relation between T
exactly, and that's a little more flexible.
That's reasonable. That's a reasonable.
I mean, just the way people would write it out in the calculus course. I'm just trying to look at the typical calculus student trying to use this functionality.
Okay, question. If I just gave the integrand here, if I were, let's imagine that this function worked differently and it didn't have it didn't have inactivated integrals in it. You just gave the integrand. Now you're going to complain about limits, but let's talk about that in a second, okay? If it was an indefinite integral, would that work?
We had that design initially. The problem is that you need to support all the syntaxes that are there for integrals, right? And now you're going to make up new syntaxes and you can't flip, you can't flip it, basically. It's just, it's a big mess.
Okay.
Somehow it's vararg and you're going to have all these things.
Yeah, okay, fine. So that's nasty. Okay.
Very.
The issue here.
But now we plan to make this work, if it's underway, to make it work for n-integrate and asymptotic integrate. It
already works. There's an example probably over there.
Okay, great. So in other words, we view, and this is part of the design of inactive, that the inactive integrate is a declarative statement.
Yeah.
Okay. And all of these things are declarative statement. They're problem description languages.
All right. So let's see. Cartesian to polar. How does it know what the names of the variables are?
It knows the coordinate systems underneath. Oh, but you already have them, right? Or you can know the X and Y from the integral.
Hmm.
I know
Oh,
that.
no.
Stephen has a point here. Like which order? Is it,
Yes.
you know, is it,
Right.
I see. So we should probably have some way to give the order.
we have
Yes.
to.
Well,
we have
what
to.
is the thing for changing coordinate systems? How does that work? How does what is that thing called?
Coordinate chart. What is the
Coordinate chart.
data? Coordinate chart data problem.
Right. So how does that work, and how does that give the order of?
You can give them. Oh yeah. You can give them there. Go open that page, Stephen. It actually has a notation for that.
Okay,
Yes.
fine. I mean, I think that there is a way.
No, good catch. That's a really good point. So let's see where that notation is. Not shown there.
I think it's in a different. It's coordinate transform data.
Oh, probably that. Yeah. Not really.
Hard to know. Yeah, it's hard to know. All right, we need to look.
Well, we can design that though, because I could, you know, so what I assume that it is, or what we want, is something like, you know, Cartesian list x comma y, and then we say polar r comma theta, or if I wanted rho comma phi, you know.
Yeah, I understand. I think we're going to have to go back and revisit this chart stuff. I mean, this is a reasonable first syntax.
Yeah, but you're right. We got to sort of extend it in the way that you describe. I should have caught that.
But I think what we're going to need is a symbolic, you know, description of a coordinate system. So in other words, just like when we were designing this, there is a way in the end, they're the H's or whatever, you know, metric tensor, things like this, which we pull out. And there has to be a sub-value of this symbolic object that represents the coordinate system. The thing that's going to get tricky is this coordinate system is going to be associated with these named variables. And this is another can of worms with formal variables versus bound variables and so on.
Potentially, yes. But here we have concrete variables that we want to go from and go to.
I understand. Sandra on our live stream is asking about integrals that can't be done, like integrate decimal
Yes, there's an example in the applications where you show an integral which cannot be done without the transformation by integrate right now. But once you apply transformation, it does
but
get
so
done.
the basic point is it supports both an activated integrate and
unevaluated. Yes,
absolutely.
Definitely. Yes. Oh yes. That's a design.
We have to fix the typesetting there. It's bold there.
I know.
It's a fix.
Okay, what about a hold? What about integrate change variables, hold of integrated whatever? Do that as well? I would do that as well.
Fine.
I would do that. I would do hold form. I mean, I would just make it a courtesy where, you know, you translate it from whatever was given to the same form of holding, so to speak, on the output.
Okay.
This is a function that's been long awaited. Yeah, we definitely need this. I don't have a problem with this. I mean, I think that we need more discussion about this inactive thing. We should make this experimental, but I think this looks good otherwise.
Thank you.
And also that needs to be italics, by the way, and lowercase c, right, or whatever it is, however that works, right? Those are dummy objects.
Yep.
Okay, desolve change variables.
So now you can probably guess how this is going to go.
Well, let's hope I can. If it's right, I can guess.
Okay. We have an even more elaborate way of describing systems of differential equations than we have of integrals.
What the heck is all of this? Okay, so that is, I'm a little confused here. So let me look at this again. Okay, this says I want this to end up with this independent variable, this integration variable. Okay. I'm not even going to ask what happens in change of variables with respect to constants of integration and so on. I mean, clearly, integrate change variables for an indefinite integral might give you a mathematically different object, correct? Than because of the change of the constant of integration. Am I making sense? When you change variables, right? Go ahead.
Yes. Yes, that's I agree with that. That in fact it's a little ambiguous for the indefinite integral case, but then people require it. So
Well, okay, no, I understand, but you've got to explain that in documentation and put it in possible issues and so on. That the thing you get, right, by changing variables might not be the same, might not be the same thing. Okay, now here you've got an independent variable, a dependent variable, and the transformation. Question: is it obvious that you want to put the transformation last as opposed to before the t? Particularly given this case, because this is the main event here. And one could imagine some future more AI world, so to speak, where you could drop this thing, just like solve in principle, you could drop, in solve x squared minus 1 equals 0 or something, you could drop the x. Do you understand my question?
I think until you establish what t is, the transformation doesn't make sense. That's my view. So you need to say what t is, and then you need to say.
Okay, but it's a bit unfortunate. You've got two variables here.
Yes, I know, but I think that that way we kind of first go, we kind of more or less go all the way the desolve kind of syntax. And
question: is it the case that you might want to make a change of variables here, where probably not, where you leave y the same but you're changing x to t?
I think it should work. If you just
no. I'm not asking the question.
No, but I don't think we need separate syntax for it. I don't think it's that.
You don't think it's that common?
No.
Explain for a second. So, I mean, let's say
I think that even if you didn't, even if it's, in this case, in principle, you could have had y in the thing that comes out, but that's like confusing.
Okay, hold on. Let's say I'm making a change of variables in a PDE from, Cartesian to spherical.
Mm-hmm.
Yes.
But usually you don't change the name of the dependent variable when you do that.
But I think it's confusing.
Well, maybe it is, but people don't do it. I mean, they say...
Right. But then they spend endless pages of explaining that what they really did was meaning this, right?
Okay, maybe so, but I'm still asking the question, if people are going to want to make that change of variables...
But they can reproduce that case. If they want to put u to be y, it should be okay.
Well, I mean, clearly you're arguing, you're making me argue against myself, because I was saying for the implicit D, you want to give the explicitly the Y as the first argument, right?
Yeah.
Which is the same type of thing.
Yeah.
More or less.
More or less.
It's just this has an awful lot of, okay. Are you sure about this?
These are going to be lists in general. The U's is going to be a list, and T's are going to be a list, and so on, right? Systems of PDEs.
Could whoever's making clicking sounds in the background try and mute? That would be Adam, I think. Yeah. Okay. Well, fair enough. Does this work with eigenvalue equations as well? And what does it do with those? Whether there's some kind of eigenvalue change?
We didn't think of that, but there's no reason, because it's the same change of variables.
Is that true? That the eigenvalue doesn't, that there's no tangling up of the argument structure?
No, I think we could have that as a first argument, just as a D.
What is the function again?
D eigenvalue, D eigensystem, and the et cetera, et cetera.
You need an operator there. That's the only thing.
Wait a minute. Okay, so there's a domain here.
Yeah, but that we can have that in DSolve and DSolve also.
Okay, so that domain, when you do a change of variables, what happens to the domain? So okay, let's start off with the basic question. In integrate, right? You clearly are dealing with, although you don't show an example of that.
Yes, there's one in there's a section on regions in the scope, which has examples for regions. But I don't think you get back a region necessarily. We might have just
Wait a second.
Sure.
Okay, so for goodness sake, show a region. Well, okay, so there's a region, but can't you do an integral? Am I wrong to think that if I do an integral, hold on 1 second here, can't I just say integrate, x to the 4th, x, y, element of disk?
Yes.
Okay, great. Okay, so now if I turn this into inactivate, and by the way, you should show people in the documentation how to do that, how to inactivate.
I don't think you should just do inactive of the integral, because like now you inactivated
Okay.
element.
I know. So then please show people when you do this. In the
don't.
No, I know. I got it wrong. But when you show people in the documentation, can you type out inactive of blah blah blah?
We should do that.
Sure.
Okay. Rather than showing just that integral there. Okay. Okay, so inactive integrate, which is perfectly civilized to write that. Okay, so there we've got that. So now I say integrate change variables. And now I'm going to say I want to change that to r theta. And how do I do this now? And then I give and I'm going to say Cartesian arrow polar. What happened?
So you have a disk.
Did I get this wrong?
Looks okay to me.
How would I write? Okay, so there's a bug here. I mean, how would I write the Cartesian to polar thing as an equation? So what I would write here is x squared plus y squared equals r squared, and y over x equals arctan theta. Am I right?
I mean, you could just give it x equal to r cosine and y equal to r sine.
I want to do this. I want to do this.
Sure, that's fine. Yeah.
Splatteroo. Okay, I better save this file. Okay.
Sure.
So this isn't right. I mean, this. You agree that this should work?
Yes. So this is. So I investigated this quite extensively 20 years ago, when we introduced bool and other things, and ultimately, these things, when you have complicated regions, most people pick a change of variables based on the function, but the region and the function may not agree on the symmetries. So, do you know what I'm saying? Like, let's say that you have something that's not particularly polar in the region, you're going to get things that are basically unresolvable. You're going to get transcendental inequalities that need to be eliminated, and we can't do it.
I understand, but I mean, you can't just splat over, just fall over and play dead here.
No. I think that this case should have worked. So
okay, but let me ask this question.
But I'm just saying that there are these there are these limits. People think that change of variables is like a holy grail, and it isn't. Particularly,
no, I understand, especially it could get incredibly weird.
Yeah,
I mean, it's a giant sort of algebraic varieties twisting into other things, and just I don't even know what this is. It's like mappings. It's like there's some like conformal mapping, right? Is one thing for in 2 dimensions, but generalizing that is really a mess.
Yep.
Okay, so just to understand, when you give a specification like this, that can be a short form for presumably, coordinate chart data of blah 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 of. I'm making this up, but it's something like this, whatever it is, right?
It's a good point to explain it that way too,
right? And that then this thing becomes, and then it turns into potentially a set of equations, right? Which is what you're going to use ultimately under the hood, right? Devendra, Adam.
Yes.
Okay. Well, now, okay, fine. So I think I understand this, but clearly, as Roger is saying, if I give a complicated implicit region here, the transformation of that under this change of variables might be do we even have a function that takes a region and changes variables for that region?
No.
We tried also built-in region. It's kind of not built to doing this kind of very intensive, reduced kind of work, where we need to sort domains and parameters and all kind of stuff. So we actually had to do some of it by hand, the transformations.
Well, okay, but I'm asking this question.
There is a you can get formulas from regions. Is that what you mean? So there is what is it called? We introduced
transform region, is that
right? No, we just introduced it. It's called
region convert.
Yes, region convert.
Yes.
Okay, but so what I'm asking is,
so we use that extensively under the hood, but no, we don't give you sort of a change of variables for regions because most of them have no variables.
I understand that. But if I'm saying, okay, so you've got a region, you put down a coordinate system on that region in order to be able to do an integral, for example, right? Right.
No, we do something that's smarter than that most of the time.
I realize that for regions, but the problem is to say it's x to the fourth, you need to quote that in terms of variables.
Yes.
I mean, in our infracalculus project, for the physics project, we hope to transcend that issue, but that is a different story. And for the future, where we're just operating, where we don't invent variables yet, and where we just have the base space, which is in this case a limiting hypergraph thing.
But basically, let me just summarize it. What we do for so underlying regions, if you take something like disk, we have multiple representations. We have multiple implicit, multiple parametric representations. Different functions want different forms and are differently capable. So to make regions work across the system, we need to have a multi-representational system.
I understand.
Optimization, for instance, want implicit forms. It really likes inequalities.
Yeah.
Integration, is only really defined for parametric forms. So even if differential geometry, they allow for implicit regions, they say, well, locally you can parameterize it because of the implicit function theorem.
Okay, but look, there's two things that are going on here. There is the change of variables affecting this, okay, affecting the measure, for example, affecting, for an integral affecting the measure, just transforming the two, right? So the other difference is when you change variables, the region is described differently. Like, for example, in this case, what we should see,
if you look at the, yes, it should be, yes.
Just R equals 1. This should turn into, let's just understand what the output should be here. It should be integrate of x to the fourth becomes r, r sine theta, whatever it is, to the fourth, if I'm not mistaken.
Yes.
Not
our cosine, well, our cosine problem.
Thank you. Yes. Okay. Right. I don't do these things by hand. Okay.
And then R probably from the measure. I mean, the Jacobian basically.
Yes. Okay. So what is the Jacobian? But then what I want R. to do in this case is this is going to be R from 1 to 1. Oh no. Let's say. Well, if it was a circle, I see. So disk, it would be R0 to 1, and then theta 0 to 2 pi.
Yes, and you want a factor of R.
Yeah. Factor of what?
Of R for Jacobian of the transformation.
Yeah. All right, but then theta goes from 0 to 2 pi. Yes.
Yes.
Okay, fine. So that's what we should see in this case.
Yes.
Okay. So really, the description, which is interesting, is we will transform from this geometric description to this essentially algebraic description.
But that's also a geometric description because that's R theta lives in a rectangle.
Right. Okay, so what we could say here, if you're saying what we could do instead is to come out with R theta, element of, rectangle, whatever it would be, 0 to 1, I mean, that's probably 0, 0, 1, 2 pi or something. Is that right?
Right.
Give or take. Okay, so you've got a choice of which of those you want to do.
Right. And people might prefer the iterated integral because that's the way things are typically.
Well, I know that, but I mean, that's a choice you can make, but maybe it's an option.
Yeah, maybe. Yes. Yes. So
whether try to preserve this. Because you might also want to preserve this. That might also be a useful thing to do. So what I'm asking is a different question. In this transformation from disk to rectangle, that would seem to me to be a useful function in its own right, having nothing to do with integrals.
Right.
And that's, right? I mean, that's changing the description of a region, which you're also doing in region convert.
Well, no, region convert just gives you a different representation of the same region. Transformed region transforms regions.
I understand, but this is a different description of the same region. Again.
No, it's a different region.
Okay, all right, fine. But so
it's a transformed region.
Okay, fine. But what I'm saying is this functionality should exist independent of it being diggable out of integrate change variables. Do you agree?
Yeah, it's called transformed region.
Okay, but I mean, but does it do it right now?
Yes.
So I could do this transformation.
Yeah, I mean, it doesn't do much for it tries to pursue. What?
It's not doing this case. It's not doing the case where.
No, it's not doing that case. No,
okay,
I think it doesn't have special cases stored for nonlinear transformations. It does a lot of things special for affine and linear fractional because that gets preserved in many.
So this is probably the place to build out this kind of, this kind of functionality. And whatever it is that we're doing with Cartesian to polar should work for this too. Right?
Probably.
I think so. Yeah, I think so. Because look, there are no names of variables.
Yeah.
There are no names of variables.
That's not a bad idea, actually.
Right.
Yes, we probably should.
Okay, fine. Then that would do this, and that would provide that functionality. And then we're doing now, just so I understand, getting out the Jacobian, that also should be a factorable thing to get out the Jacobian of the transformation of the Cartesian to polar, whatever. And that presumably you can get from coordinate chart data. Yes?
Yes.
Okay. Okay. All right. Well, this looks good. All right. Anything else on this?
Residue sum, maybe?
I'm sorry?
Oh, residue sum.
No, I understand. These ones here, this looks straight. I mean, the syntax is, there's nothing complicated about the
No, it's just what we did for dsolve in version 13.0 has now been done in 13.1 for rsolve, etc. We just
it doesn't get weird in any way.
No, it works perfectly, and we just
tell me the syntax, please.
Yeah, so you just need to say that something is in vectors, and there should even be an example in marked blue somewhere. Just hopefully there you are, somewhere over there.
Oh, I hate this.
Yeah,
I hate this so much. I hate it so much. I mean, I understand this is what we're doing. Hopefully we will have some summit discussion about symbolic vectors soon. I hope that's that's a post 13.1 thing, but it needs to get scheduled. Well, I'm not a fan, but whatever. I mean, this is consistent with what we're doing elsewhere, so it's
exactly
fine.
The same. Yes, and just to make sure.
Come on, you can do better. That please don't use capital letter variables. We tell users don't do that. Please don't do that in documentation.
Okay, sure.
And you know the rules about this kind of documentation and how we should be setting it up.
Yes.
Okay, we're gonna look at this, and then we're gonna have to wrap this meeting and continue this at a different time. But we need to try to get through these this week. So I don't know when it's going to get rescheduled, but sometime the next day or two. All right, let's look at this. This, I think, should be straightforward. He says, famous last word.
We had with function poles. You recommended this last time, so we just did it. We just have.
So sum over residues of all residues. Now, what if I want just the residues within a particular contour?
Yeah, well, that doesn't make. Would you go constraint? Then that should work then.
Constraint argument, yeah.
Oh, sorry, Adam's here, so he knows.
Okay, so this is using the listed version, which is probably right because again, it's an optional constraint. Okay, looks good. I think this looks fine. I don't have an objection to this, although I am asking the question, if I want around, the unit disk, can I give, is there a convenient way to give the constraint of the unit disk?
I think you could say x or right up z less than equal 1. So
No, I know that. I can do it mathematically.
Yeah,
okay,
geometric language probably won't work here that well because we are talking about complex variable. So geometry deals with real variables.
I see what you're saying. I see what you're saying. Okay, so the unit disk. Okay, so that raises the question of a complex disk object that represents a disk in the complex plane, different from disk in the a real geometric disk. Is that right? Or is there a different way to think about it? Do you understand my question?
Yeah.
Yeah. So yeah.
I mean, we really didn't want to build complex geometry yet. We
got
to get better at real geometry. But you could say re-z, imz elementa disk, and it would still be correct.
Bluff.
Yeah. Or we could say that we treat 2D geometry as the complex plane.
Yeah. Well, I mean, you'd have to say Z is an element of disk, and then that's kind of going down a slippery slope.
Yes.
But it's not ridiculous. I mean, it's not as if that's changing, right? I mean, the mapping of complex numbers to the sort of Cartesian plane is a pretty well-established thing. I mean, it doesn't have to be that way, but it is a well-established way to think about complex numbers.
Yes.
And it's certainly the one that we use in a very fundamental way in the complex, in our data types and so on.
Yeah. From a topology point of view, complex numbers add nothing. It's just a real plane.
Yeah, but right. But I mean, so I kind of think we should be thinking about, for this particular case, this is a very, very common case where you say, I mean, and also in the end, we want named contours, presumably. Like, the Bromwich contour or whatever else it is. Am I making sense?
Not yet, but yes.
No, I understand, but in principle, that contour that contour depends on the function, depends on the positions of the poles, yes? It's like to the right of all the poles.
Yes.
But we could imagine that thing being a construct in two-dimensional planar geometry where instead of giving poles, we say, here's our inventory of avoidance points. Go work with this.
Yes, but we really don't want to introduce that now. I mean, we are thinking about that. We're planning that, but this just is like a whole can of stuff that's exploding. If you want to bring that up now.
No, I understand. Okay, so we're not doing that yet. All right, I'm just going to look at one more thing, and then we're going to. I mean, we're not actually going to look at one more thing, but we're going to.
There is just one more thing: the structured arrays. Oh, sorry.
I'm aware. Yeah, I'm aware. I mean, well,
that's not a quick thing.
No, it's not a quick thing, and I'm just want to get some sense of how horrifying it's going to be.
It's not horrifying.
Of course not. It's brilliant, I'm sure. Okay, that's what I thought it was. Yeah, I mean, I just worry so much about all the other random things that might or might not support this, like array plot, for example.
It's matrix Q.
Nice.
Yeah, we have made a list of things. We try to keep it as complete as possible, but we might have missed.
No, I mean, the core framework that we built with Rob and Jose does just that. Like if there is a special operation, it uses it. Otherwise, it turns it into a normal matrix.
Yes.
I see.
Yeah, it'll all work, all the operators. And they'll be much faster in many cases because we know its permutation, so it goes much, much faster.
And how do you pack it in? I see. So okay, this isn't going to be so horrifying.
Actually, it's a lot of work has gone designing this, and what we have at the moment is quite lightweight. I mean, it doesn't affect the user that much. And it's scalable to large matrices. It might even
So
help us.
if I take an upper triangular matrix and I transpose it, okay?
Then you
I
get a lower
assume,
triangle.
so if I take that upper triangular matrix
Yes.
and I say transpose, lovely.
It's
And
quite
then I
nice
say,
to.
array plot that.
Yes. Should
Lovely.
work. It is very well tested function. It's already gone through QA, etc. A lot of work has gone into this already.
Devendra, why do I feel that as you, okay.
I mean, normally we don't do that. QA looks at after we review it, but this time we have.
No, but the kinds of things that Stephen will spot is sort of, I don't think it's on QA's radar, particularly,
Yeah.
you know,
Maybe.
like entanglements far out in the language.
Yes.
Right. Yeah, I mean, like, I don't know how all these work. We need to review these, but this should be a fairly fast review.
Mhm.
Good. I would predict half an hour. I also would like to ask the question, how does this relate to data structures? And should there be a data structure corresponding to upper triangular matrix? I think yes. You see what I'm saying?
Let's have that discussion next time.
Okay, fine. I'm putting that on the radar. Okay, thanks, guys. Okay, people following these live streams, we are actually about to enter another design review live stream. So if you want to, see you there.